네, 여러분 안녕하세요. 네, 안녕하세요. 지금 뭐 아직도 수강 정정 기간인 것 같은데요. 네, 뭐 제가 확인해 보니까 네, 약간 늘었어요. 네, 그래서 아마 다른 반들도 늘어가지고 아마 이제 그 4분 반이니까 충분히 이제 하실 수 있을 것 같고요. 그래서 뭐 오늘부터는 네, 본격적으로 수업을 하시도록 하겠고, 네, 뒤에 보시면은 네, 이게 녹화가 되고 있습니다, 나름. 네. 그래서 네, 질문하시면 방송을 타고 싶다 질문 네, 하시면 되겠고요. 그래서 네, 영어 강의니까 네, 영어로 네, 시작을 하겠습니다. Okay, so hello everyone. So thank you for coming. So today is the first class for the the real content for the probability. So first, so let's start from the why we learn these probabilities. So let's first consider about the flipping a coin. So flipping a coin, we want to know what's the result. Okay? Then two approaches might be possible. So one is deterministic approach. That means, okay, so in order to know the result of the flipping coin, we actually use all of our knowledge for the dynamics and collecting all information for the what's the force, what's the amount of the force to the flipping the coin, right, tossing, and what's the direction, and what's the current gravity, and what's the law of the gravities and the motion of the all the physical knowledge. Then we might be able to predict the result of the flipping coin, head or tail. Definitely, that's a deterministic approach. However, there's pros and cons. Pros means advantage, and cons means disadvantage. First, pros. Pros of this deterministic approach is we might be able to get a deterministic answer. That means we can decide, okay, this is a head, or okay, this is a tail. Deterministic. However, cons, disadvantage is it's too much complicated. Definitely, you can think it's too much complicated, and probably may or may not we might not be able to get the answer itself. So that's the the deterministic approach. However, there's another approach. The other approach is probabilistic approach. That means we just model this coin as a fair coin. Then we just think, okay, and we assign some probability for each outcomes. That means, okay, so the probability of the getting head is 50%, and getting tail is 50%. Then in this probability approach is, first, good thing is, it's very simple. It's very simple because we model it as a fair coin. However, bad thing is we cannot answer the the deterministic answer. We cannot predict, okay, this is a head. We cannot say it like that. We just say with probabilities. That actually shows, this simple example shows why we learn these probabilities. We learn this probability and random process and random variables because many problems in engineering and or in physics or in many other fields like business or the marketing or finance or computer science, many fields can be simplified with this the probabilistic approaches. So for example, so we want to answer what's the download rate of the for a movie using the internet. Maybe in this age, how long it takes to download one movie. Maybe if you use LTE, 5 minutes. Maybe it's the advertisement. But maybe if you use some some file sharing program, my experience is less than an hour, right? Less than an hour. So that means you can actually start to download, then watching video, then the length of the video is longer than the the download time. That means you can, without waiting, you just watching and downloading. Okay? So that's actually fast. So actually, the download speed is determined by error rate. So if you have a high error rate, you need to download it again and again. That actually limits the download speed. Then what's the meaning of the error rate? Error rate means the probability of the error. All right? So you can actually calculate your download speed based on the probability of the errors when you transfer the data. Do you have some background of the quantum physics? So in the quantum physics, they say everything is a probability. For example, some electron can be here or can be here. Can be here with 50% of percent and can be here with 50% of the chance. That's some quantum physics. 여러분 quantum physics 아시나요? 예, 양자역학에서 불확정성의 원리 그런 거 그게 다 확률이죠. 네, 그게 바로 확률입니다. Okay, so that's why we learn these probabilities. Okay, then I believe you already know what's the probability. Okay, so for the fair coin with head, usually the fair coin has the two faces. One is with the number, the other is with the grandpa or 할배 or generally. So people usually say this side, face side is head, and this number side is tail. For the fair coin, so what's the probability getting head? 0.5, 50% or half. You already know. Okay, then we have a dice. One, 2, 3 point, and it has the 6 faces. And in 6 faces, there's numbers from 1 to 6. And when you're rolling a dice, what's the probability to get an even number? Even number is 짝수. Okay. What's the probability to get an even number? 0.5. Yes. 50%. You already know that. Okay, then another question. So when you have a blind date with a member of the girls' generation, what's the probability to see the member of the 태티서? Do you know girls' generation? You know? Then do you know what's the 태티서? 태티서 is some subgroup of the girls' generation with 태연, 티파니, and 서현. Then, in girls' generation, okay, so it used to be 9, but recently one member is get out, so in total is 8. So the total probability is 3 over 8. Okay, so here is some, the English for mathematics. The answer is 3 over 8. It is, we say, 3 over 8. EIGHT. 3 over 8. 3 over 8. In Korean, 8분의 3. Sometimes, I'm confusing, so sometimes I'm saying this one, 3분의 8, but it's confusing. So because, in English, it's starting from the denominator first, but the numerator first, but in Korean, it's the denominator first, so it's confusing. But anyway, in English, it's 3 over 8. Okay? All right. And do you know what's the blind date? In Korean, meeting or 소개팅. Okay. And in the same blind date, what's the probability to see Jessica? 0, because Jessica is the member to to get out of this the girls' generation. Yeah, so there is no chance to see Jessica. Okay. Because I made this example 2 years ago, but in this case I have to change this example to the girlfriend or AOA the other ones. 여러분 걸즈 제너레이션 이제 한물 갔나? 수능 시대? 네, 또 다른 걸로 바꿔야겠어요. 네. Okay, and the next question, another example. What is the winning probability of the the computer online computer game like the League of Legends? What's your winning probability of the League of Legends? LOL. What's the winning probability of yours? Okay, so then how to approximately estimate it? How to estimate it? Any idea? How to estimate your winning probability? It's simply, how can you aid? The number of total games divided by, number of total games is the denominator and number of wins. Number of wins divided by number of total games. That's your estimated total, the winning probability. And what's your winning probability in an LOL match? How many students play LOL? You are lying. Only 2? Only 2? No, I shouldn't be. I think almost half, at least half should play this one. You believe it or not, your winning probability of the LOL should be 50%. Should be. Do you know why? Huh? Win or lose. So there are 2 choices, but it's not fair coin, because this LOL match, especially in the ranking system, is designed to get your the winning probability to be the 50%. Because once you win, then you next match gonna be the higher level of the other players. If you want to lose it, then your next match is gonna be with little bit the less well players. That's why finally, if you keep going your the LOL match, then your winning probability is gonna converge to the 50%. That's your ranking. 예, 여러분 제가 무슨 말인지 아시겠죠? 네, 그러니까 여러분, 네, 결국에는 50대 50이니까 네, 너무 스트레스 받지 마세요. Okay, so then another question is, okay, so what's the winning probability of the LOL match when your top solo is Timo? Is it gonna be higher or lower than when the top solo is not Timo? Do you think it's gonna be your winning probability getting higher or getting lower? If you're lower, that's what people are saying. But in my case, it doesn't matter because I always lose. In my case, my LOL match is not 50%. I don't know why. Anyway, so basically, you all know what's the probability already, right? However, the problem is, even though you all know the probability intuitively, but actually it's not we, so it's not us. So some people, especially some mathematicians, need more concretely. They want to more concretely define the probability in mathematics. That is the probability theory. So probability theory is the way to mathematically define the probabilities. So we're gonna little bit look at what's the probability theory and what's the mathematical definition of the probabilities. Okay, so let's consider flipping a coin. we flip a coin. One, we flipping a coin. Second, what can be the possible outcome of this flipping a coin? Head or tail. That's the two possible outcomes. Head or tail. Some people might say it might stand up, like with its edge. Is it possible? Possible. 여러분 타짜 안 봤어요? 여러분 타짜 모르나 잘? 타짜 만화로 봤다. 만화 봤다. 만화. 4부에 보면은 4부까지 봤어요? 아, 제일 마지막 게 4부예요. 원아이드 잭이 3부. 그 1부와 2부는 그렇고 3부의 주인공은 서울대 영문과 학생이고요. 네. 원아이드 잭, 그 뚱뚱해가지고 네, 살 빼서 훈남이 되는 거고 4부의 주인공은 카이스트 학생이에요. 네, 고려대 학생은 불행히도 안 나오네요. 네, 그래서 4부에서 대학원생들한테 물어보면 아는데 아는 대학원생들은 아는 학생들이 있는데 네, 여러분 아직 학부생이라서 약간 옛날 거라서 모르는데 하여튼 주인공이 잡혔는데 네, 잡혀서 그 이제 뭐 빚을 져가지고 도박하다 빚을 져서 잡혔는데 앞면이 그러니까 동전을 던져서 이제 나쁜 놈이 동전을 던져서 자 앞면이 나오면은 뭐 물에 빠져 죽고 뭐 뒷면이 나오면은 뭐 저렇게 해도 죽는 거다. 무슨 뭐 매장에서 뭐 무슨 뭐 생매장에서 죽는 거다. 대신 엣지가 나오면 살려주겠다. 서면은 동전을 던졌는데 네 만화고 주인공이라서 네 엣지가 나서 살아요. 네, 그래서 엣지가 나올 그러니까 설 가능성도 있다. 하지만 우리가 페어 코인을 할 때는 head or tail. Okay, so the outcome can be head or tail. And here, what's the probability of a head? If we are assuming fair coin, 0.5. And the probability of a tail is also 0.5. Okay. In here, in the probability theory, we say we actually perform experiment. Experiment means flipping a coin. Then, as an outcome of the experiment, we have possible outcomes like a head or tail. This is outcome. Or we say this is an event. As an outcome of the experiment, we have an event. So this is an experiment. We performing experiment, and as an outcome of the experiment, we observe event. So in this experiment, we have two events. One event is head, the other event is tail. And in each event has its own probability measure. So we assign some certain number as its probability. So this one. So for the event of head, we assign 0.5. And with the event of for tail, we assign 0.5. This is a probability measure. Okay, so let me get back. Okay, so the event is an outcome of each experiment. And we say sample space. Sample space is set of all the possible outcomes. In this case, sample space is head or tail. This is a sample space S, or we say omega. We represent as omega or sample space S. This is a head or tail, and each head and tail is an event. And here, in the probability, probability is defined in this way. Probability is a function that maps an event two events in a sample space to a real number. Okay, so let me get back. So this is a sample space, S. Again, sample space is when we performing a experiment, the set of all possible outcome is a sample space. And in the sample space, there's an event. There's an event. Okay? Event is an outcome of the experiment. Then probability is mathematically defined by as a function that maps that mapping function that maps this event to a real number, a certain real number. But this real number, but this function should satisfy the three properties. First property is for any event A, the mapped real number should be non-negative. It should be larger than or equal to 0. That's the first criteria. It should be satisfied. That means minimum value of this real number is 0. And second one, probability, because this is an event. So this event is any subset of this whole sample space. So it can be S itself. So if we map this S, the whole sample space, into the real number, that real number should be 1. Okay, so the probability of S equal to 1, always 1. And the third one, any disjoint event, disjoint means this is E1, and if this is E2, if there is no overlap between these two events, then that's a disjoint. If it's some overlapped region, it's not disjoint. Okay. So if any number of the disjoint event, if we some unions of A1 to A2 to AN, that probability should be equal to sum of the probability of each event. Okay? So these three properties should be satisfied. And we call these three properties as the axioms of probabilities. So the basic probability are basic properties of the probabilities. That means because any of the probability can be negative, and the probability of the whole space is 1, that means probability is assigned between 0 and 1. Is it right? So by these three properties, probability cannot be larger than 1. Am I right? Am I right? Because the probability of A plus probability of AC is complementary of the A or Yojipap, right? A and AC are disjoint, definitely disjoint. That's why that's the definition of the complementary set, right? So it should be equal to probability of A union and A complementary by the the third properties. And this one is probability of S whole sample space, and this is 1. So A should be non-negative, probability of A should be non-negative, and probability of A complementary should be non-negative. And this is 1, so both should be less than or equal to 1. You got it? So that's why. So basically, the probability is as a mapping function to the real number. That real number should be from 0 to 1 by this probability theories. Okay? So this is the simple definition of the probability in mathematics. So here in our the simple example of the flipping a coin, so probability of a head is 0.5, probability of a tail is 0.5, probability of head or tail is 1. That is the definition of the probabilities. Okay, so okay, let's look at this example. Okay, so let's consider we are flipping 3 coins. 3 coins. Assuming that 3 coins are all fair coin and they are distinct to each other. Okay. First question is, what's the sample space? Again, sample space is set of all possible outcomes. Okay, so when we flipping, the 3 coins, what's the number of the possible outcomes? How many outcomes are possible? 8. Okay, so it's a fair coin. So ideal fair coin. There's no stand-up. The answer is number of Gauss generation. Remember, 8. So then, what gonna be the sample space? Sample space gonna be consist of 8 elements, 8 events. So what's the 8 events? So sample space S gonna be H, head. Yes, head, tail, tail. Then similarly, tail, head, tail, head, T. So the answer of the first one is the sample space is this one. Head, starting with the head to the tail. In total, with 8 events. Second, how many possible outcomes? 8 outcomes, right? So when you're flipping 3 coins, then what's the probability of head, tail? Where's the head, tail? Okay. What's the outcome? What's the probability of the head, tail? 1/8, right? Because we are assuming the fair coin. That means all of these 8 outcomes are equally probable. Then the probability is going to be 1/8. And what is the probability to see 2 tails? (3/8) Really? 맞아요? 3/8. Let's count. Two tails. Here's one. This one. This one has 2 tails. And this one also has 2 tails. 2 tails. So among 8, 3 outcomes has 2 tails. So the probability gonna be 3/8. Then number 5, what is the probability to see 2 tails or 2 heads? 2 tails or 2 heads? 3/4. Let me count. Here's 1, 2, 3, 4, 5, 6. So 6/8. Or 3/4. So it's easy. It's just counting, nothing, right? Then number 6. What is the probability to see 2 tails and 2 heads at the same time? 0, because there's no such outcomes. 0. What's the 0 in Turkish? Huh? Space? Space. Space? Space. That's something similar, okay? In Chinese, I know it's Liang. In Japanese, I don't know. Do you know any other foreign language?
I know Japanese, but I know
Okay. I don't know either. Just 0 or in Korean, 영 or 빵. 네. Okay, so you are so familiar with this in the probability. So maybe it might be the first time to see what's the mathematical definition of the probability. But even though you know intuitively, so everything is very intuitive. Okay, so let's look at some of the obvious consequence of this the probability axioms. And first, what's the probability of the null space? It's not null set. You know what's the null set? Null set is a set with no elements. That's a null set, and we usually note with B. What's the probability of? Because the null set is a set, it is already a subset of the whole sample space, right? So it should have its own probabilities. It should have its own mapped numbers. What are the mapped numbers? Intuitively, 0. Mathematically, how to prove? Proof is probability of S is probability of S and union of this null set. And this one and this one is disjoint because the intersection is null. So probability by the third axioms of our definition. It's null. Then this one and this one is 1 and it should be 0. Mathematically, you can prove in this way. But without this mathematical proof, you know intuitively. Okay. And second one, probability of a complementary of any set A is equal to 1 minus probability of A. We already proved it, right? We already proved it by showing the probability of S is 1. You know how to prove it. The second one, okay. Third one. In general, there's two sets, two events, A and B. The probability of A union of A and B. Okay, so let me say. So here's another second English for the mathematics. In the set, B, this note the 합집합 of A and B. In English, we say union of A and B. Union is in English like the United States or United Nations, UN, or United Kingdom, something the collected together. That's a union. So 합집합 means union. Then A, this notation is in Korean, it's a 교집합, but in English we say intersection. Intersection of A and B. That is 교집합 in Korean. And AC, this C note complement. Or complement in complementary set. Complement is the noun, and complementary is adjective. Am I right? Adjective. Anyway, so this C denoted the complement. In Korean, 여집합. Okay. Okay. So anyway, the probability of union of A and B is given as probability of A plus probability of B minus probability of intersection A and B. Or in the probability theory, usually people say the intersection of A and B means it's a probability that event A and event B happens together. Am I right? That's the definition of the intersection. Am I right? So that's why people usually omit this in the intersection notation and just use AB. So when you use the AB, that means the event that commonly occurs between A and B. That we usually denote AB. That is equal to the A intersection B. So basically the probability of A union of the A and B is equal to probability A plus probability B minus the probability of intersection of A and B. Can you see why? So intuitively, is it right? Or it is right. So the intuitively it's right because by adding this one and this probability that A and B occurs together is counted twice. So just we subtract 1. So the intuitively that's right, but because this is the class in university and you pay some money, so I have to teach you some more formal way. So formal way to say is simple. So by using the 3 axioms, we can prove that probability that A union and B is equal to, because in the set theory, this S and A and B, this one is A union B is this part. This one can be divided into A plus this part, right? So this one is, and definitely A and this part they are disjoint sets because there is no overlap between these two. So we can say this is A plus probability that B intersection with A Am I right? Okay. Up to this point is right. So then let's look at the B. Probability of B. Probability of B is equal to this probability of B is, okay, again, when it be A, then let's look at only B. This B is the union of two disjoint set with this one and this one. Two disjoint sets. Right? So probability B can be written as A intersect B plus probability of B intersect A complement. Right? So if we merge this one and this one, we can get this result easily. So this is the formal proof. But without this formal proof, so you can easily, you can intuitively see why. Okay? So you got it? You got the proof of this the relations? You guys all know? 자, 여러분 이해되셨나요? 네. Understand? Understand은 약간의 콩글리시예요. 영어로는 보통 이제 이렇게 하죠. Got it? Yes, I got it. 뭐 이렇게 하죠. 제가 초등학교 때는 이렇게 선생님이 됐어요. Understand? Understand? 모른다 stand? 네, 쌍팔년도, 네, 88년도 당시에 제가 초등학교 다닐 때 개그입니다. Understand, 모른다 stand. 네. 재밌어요, 지금도. Okay, so third one. First one. If A is, what's this notation? This notation means A is a subset of B. Again. So when we say A, this notation and B, that means A is a subset of B. Subset. Subset. What's a subset in Korean? 부분집합. 네, 부분집합 is a subset. If A is a subset of B, probability of A should be less than or equal to B. Can you prove it? Is there anyone can prove this one? Intuitively it's right, but anyone can prove? 오케이. 여러분 이거 뭐 할 수 있을 것 같지 않아요? 네. 나와서 한번 해보세요. 끄덕였잖아. 뭐 말로 한번 해보세요. 네. If you want. 다시 잠깐 천천히. 오케이. Again. 한국말로 하셔도 돼요. 네, 천천히.
A 여집합이랑
There's a complementary of A.
B의 교집합이
Intersection between A complementary and B. Probability of this one. This one should be larger than or equal to 0. Okay, so let's see this one. Okay, so in the Venn diagram, you know what's the Venn diagram? Okay, so graphical presentation of the stat theory. 제가 이렇게 표현하니까 되게 있어 보이죠? graphical presentation of the set theory 이러니까 되게 있어 보이죠? 그냥 집합을 그림으로 그리면 이렇게 표현할 때와 graphical notation of the set theory 이럴 때 좀 차이가 있어 보이지 않아요? 네. Anyway, so this is B, and here's A. Right? Then this one. Complementary A and B, intersection B is in the rest part. Right? Okay, then yes, because this is non-negative, definitely. Okay, so the hint it's like that. So the very close. So probability of B is equal to, because the B is probability of A and union of this one. Right? Am I right? And this one is in this joint. Right? So this is given as the probability of A plus probability of A complement intersection with B. Here we can present in this way. So here non-negative, non-negative, non-negative. That means this one should be larger than or equal to this one because it is non-negative. So very close. 90점. 네. Okay, so basically you can easily prove all of this, the obvious consequence of these product axioms. So as you see, this probability theory has very strong relations with set theories. They are almost similar, very similar, right? So you already see something similar equation from the set theory. 여러분 이거 정석 제일 첫 장에 나오는 공식이죠, 맞죠? 그러니까 그 number of element 살 때 이렇게 세야죠. 이걸 뭐라 그러지? 드모르간의 법칙? 아닌가? 드모르간의 법칙 이거 아니에요? 네. 드모르간의 법칙이 뭐예요? De Morgan's law in the set theory is the intersection of A and B and the complement of the whole intersection of A and B is equal to complement of AC and union of BC. This is the De Morgan's law. The synonym of this De Morgan's law in the probability can be rewrite as 1 minus probability of A intersection of B is equal to this one, 1 minus probability of A plus 1 minus probability of B. And because this is your union, here we minus this one and this one. This one and this one, then what's the right way? And then we have to subtract the intersection of this one and this one. The intersection of this one and this one is it's a 1 minus probability of A intersect with B. Maybe. I think it is right. So something similar to this one. This one is, the sum. So the basically, what I want to say is the set theory and the probability theory, they are, the fundamentally equal to each other. So you can convert all of the, the equations in the set theory to the probability theory. Okay. Okay, so nothing important. This one. Okay, so let's look at some. Let's look at example. Okay, this is a simple example. Let's consider you are monitoring a traffic. So sometimes you have some the part-time job to count how many cars are moved through on the road. Not in these days. These days it's not that you may not be able to in these days, but 10 years ago there's some the part-time job like counting some cars. When you're monitoring a traffic, then you classify a vehicle as a car or a bike. It's a car or bike. Also, you classify a vehicle as a fast car or the fast bicycle if it moves with the speed of more than 60 km per hour or slow otherwise. Then, based on the observed data, you build a probability model. That is, probability of car is 0.7%. Not percent, 0.7. And the probability of fast is 0.3. And probability of it's a car and fast, it's a fast car, then that's 0.15. Then find the following properties. BF means fast bike. And the union of car or fast. What's the probability? And blah, blah, blah. Okay, so I will give 5 minutes. Okay, please think about. 자, 여러분, 이 문제 풀어보세요. 내가 5분 드릴 테니까. 네. 이게, 네. 뭐, 여러분이, 네, 명문 고려대 학생인데, 네. 중딩 문제를 내서 미안해요. 네, 중학교 수준도 아니죠, 네. 초등학교 수준의 문제를 내서 죄송합니다. Okay, so, you done? You done? So it's easy, right? It's very easy. There's the many way to solve it, but most convenient or the most easy or the most the dumb way is making a table. So we have here is the two kind of the classification. One is car or vehicle, car or bike, and second is fast or slow. And what's the probability of fast car as given in the problem? 0.15. And the probability of car is 0.7. So probability of slow car should be 0.55. And the probability of fast is 0.3. That means fast bike should be 0.15. And this one should be, if we add these four numbers, it should be 1. Ichi in Japanese. Ichi. In China, Chinese, E. Okay. So in Korean, il. So it should be 1. So that means this one should be 1.5. Then you can easily calculate all of them. What's the probability of BF, that means fast bike, point 15. And what's the union of C and F? C and F, that is point 85. And what's the BS? BS is this one. And what's the B union of B and F? B and F, union of B and F is this one and this one. So 0.45. 오케이? 뒤에서 이거 보여요? 뒤에서? 제일 뒤에서 이거 보여요? 제가 쓰는 거? 이게 이 펜이 좀 약간 한데. 아, 네. Okay, so any question up to this point? Any question up to this point? Okay, so if you have no question, so let's move to the next topic. Conditional probability. So conditional probability is like that. So it's the probability that event A gonna be happen given the occurrence of the event B. That means we already assume that event B is already occur. Then what is the probability that event A gonna be occurs? So that's a conditional probability. So we say, in note, we say probability A given B. Okay? That is, in the mathematically, conditional probability is defined by probability that A and B happen together divided by probability of B. This is a conditional probability of A given B. So it is like that. So your winning probability in LOL match, this is just a probability. However, we have some conditional probability, that is winning probability given Timo is a top solo. This is a conditional probability, right? So in this case, event B is Timo is my top solo. So we assume that event is already happened. Timo is already my top solo. Then what's the winning probability? Definitely, this probability is different from this probability without conditions. So that's the concept of the conditional probabilities. So conditional probability is only defined when this B is, the probability of the B is not zero. Because B should be happened, B should occurs. If the probability of B is zero, then B never occurs. But in that case, we cannot define the conditional probability. So conditional probability is defined only when this probability B is not zero. Then conditional probability is interpreted as the relative probability of A, assuming that B already occurs. Okay, and here, and more important thing is, A is a matter of the probability. That means event A may or may not occur, because A is the matter of the probability. However, in this conditional probability, B is not the matter of the probability, because B is already happened. So B is fixed. B is fixed, totally fixed. So it's not under the probability. You got it? Okay, so in here, in this probability, my top solo may or may not Timo. So it has a probability of the Timo, it has a probability of not Timo. However, in second one, my top solo is fixed or already determined as a Timo. So the top solo itself is not the matter of the probability. So that's the basic concept of the conditional probability. So A given B, this conditional probability can be considered as the virtual event in the virtual sample space of B, because our whole sample space is B, because B is already happened. Okay, so it's different. Okay, so in the diagram, originally there's S, there's A, and B. So usually this total S is my sample space, and this A is a probability. However, when we say A given B, we only look at we assume that B happens, so we only look at this part. So this part is my whole sample space. If B is given, then A given B is the relative probability of this portion. B is already happened, then what's the probability that A gonna happen? That is only this part. So that's why, mathematically, it is given as probability of A intersection with B, this part, divided by whole probability of B. So this is the concept of the conditional probability. So because it's already, the time's up. So we're gonna keep discussion for the conditional probability in the next session on Thursday. 자, 여러분 이제 오늘은 여기서 마치겠고요. 네, 여러분 수고 많으셨고요. 다음 시간에 이제 컨디셔널 프로바빌리티에 대해서 좀 더 이야기를 해보도록 하겠습니다. 네, 수고 많으셨습니다. 네.